Okay, good afternoon, everyone. Thank you very much for coming. My name is Luca Bandini. I am a senior product consultant for Tableau, based out of the London office. And this afternoon, it will be my pleasure to be your guide through the wonderful world of level of detail expressions. People in our line of work, people like us, are known for their ability to harness the power of data and generate insights that drive decisions at every level in every industry. We're also sometimes known for our questionable ideas around what we consider cool and fun. I, for example, enjoy in my free time to hack my favorite data visualization tool to make pictures of my face using polygons. Oh my lord. Laughing at me now, but you're not that different, are you? Because out of all the things that you could be doing right now at conference, you have decided to attend a session that has a horrible pun in the title, and that is about what is quite possibly the most complicated stuff that you can do with Tableau. So give yourself a round of applause. Okay, on a more serious note, who here has used level of detail expressions before? That's good. I'm seeing a lot of hands. That's what I was expecting from Jedis. Okay, so for those of you who consider themselves new to level of detail expressions, I just want to give you a fair warning that this is not going to be an introduction. It's not an introductory session to LOD where we go through what LODs are and how we can use them. This is a session where we go through some of the most advanced use cases for these expressions. And with that, I don't want to say that if you don't consider yourself an expert, you should leave. This session can be useful for you as well. You'll be able to get an idea for what the power of these expressions is. And hopefully, you will see some examples that are relevant to something that you have tried to do in the past, or maybe you'll get some inspiration for things that you want to try to do. This session is recorded, and you will also get the material, you will get the workbook. So if there's anything that you find interesting, you'll be able to sort of reverse engineer it or watch the step-by-step instructions in the video. Okay, let's take a look at what you can actually expect from the session. If you've been using Tableau for a while, you've probably realized that out of all the things that you can do with desktop, roughly 95% is either very easy to do or very easy to Google. There's a lot of excellent material online. We have training videos. We have an excellent community. We have partners who love to create crazy examples of stuff that you can do in terms of advanced analytics. So there is a lot of material out there. But for the remaining 5%, you can go crazy trying to figure it out yourself or trying to find the right words, the right query to find some information on Google. So my goal for this session is for you to leave needing to Google a little bit less and being able to do some of these more advanced analytics by yourself and potentially maybe even contribute to the discussion on the community with your own examples. Okay, how are we going to do this? We're going to look at some examples, as I said, and the main theme around these is advanced analytics scenarios or filtering scenarios that are made possible or easier by LOD. I'm going to start with the first one. This is a classic, just to warm up a little bit. I've also been told that this is one of the original use cases for LOD. We do have some devs in the room. Is that true, that you developed this, LOD expressions with this in mind, being able to aggregate at deeper level? Yes. Okay, so just to warm up, what are we looking at here? We have a visualization that gives us a view for units sold in every industry by our company. By the way, this is completely fake data. And we have a threshold here of 6%. That means if we sell more than 6% free units, if we give to our customer more than 6% of free units compared to what we sold in total, that is not good. So the problem with visualizing data at this level is that we lose some information about what's in the next level. We don't know if within some of these industries there are some customers that have been given too many free units. And that's where LODs come in. We are able to control the aggregation and define it to give us whatever we want. So what you're seeing here is that in agriculture, for example, this is something that we can see at this level. We have given our customers too many free units. So we are above 6% of free units. In other industries, we haven't overall. But these tiny dots flag that we do have some customers within these industries that have been given too many free units. And then if I click here, it will take me to the next level. And again, this is fake data. Don't go look for Dell people and ask them how they got free units. This is not Tableau data. Now we know that there are some customers at this level that have been given too much free stuff. And we go to the next level and we can see who they are. And of course, we can go back and do that for other industries as well. So we know that in transportation, there are 3. And if I click, I'll be able to see who those customers are. So this is an easier example of how to use LOD to aggregate data and display data that is at a deeper level than what you have in the view. Because now we're creating a calculation. We have a calculation that gives us a result, including customers, and customers are not in our primary view. So how do we build something like this? Let's take a look. So we start from a very easy visualization, just like this one. We have our bar chart. We have our discount rate for every industry that we operate in. I just need to add a little placeholder. This is a little trick. I will add this calculation to have something in the view that I can use as a placeholder. And then I have this calculation here that gives me customers above threshold. Just make it bigger for you so you can read. So what are we doing here? We calculate, let me make it bigger. We calculate our discount rate as free units divided by the sum of total units. And we are aggregating that metric at the level of industry and customer name. And again, customer name is something that we do not have in the view. We are adding that. If that number is bigger than what we have defined with a parameter as the discount threshold, then we want to return the customers. We want to see who those customers are. If I add this calculation to the detail of this view, you see here, we are returning the customer names for the industries where that calculation is valid, it's true. For everything else, we have null. So the bar disappears. And now it's just a matter of formatting a little bit. I can turn this into a circle. I can make it a dual axis. Synchronize, all of that stuff. One more little trick. We now have one single dot. This could be good depending on what sort of visualization you're trying to build. If you have 1,000 customers within that industry, you don't want to have 1,000 dots. But if, like in this case, you only have a handful, you might want to see at this level how many customers do we have that respect that condition. And to do that, we can just add an index calculation and multiply this number that we have here and compute this calculation using customers above threshold. And that gives us a count of how many customers within every industry we have that have been given too much free stuff. Making sense? See some nodding, I like that, cool. Okay, let's go on and take a look at our second example. This is an example of proportional brushing, one of those keywords that is hard to find if you don't know what it means. Proportional brushing is a fancy word for looking at the contribution of a portion of our data to the total. So in this case, we're looking at sales over time in Latin America. And it might be nice to see, compared to the sales over time for the entire Latin America, how are Brazil sales? What's the contribution to Brazil to the total sales of Latin America? And it's quite easy to do that with LODs. So if I click here, I get a nice little bar that tells this is Brazil, this is all, this has not been filtered by the action that I have performed. And down here, it's just a very simple calculation to divide sales for Brazil by total sales. and it gives me the percentage contribution for every month of Brazil sales to Latin American sales. Okay, let's take a look at how we build something like this. Oh, not this one, this one. Okay, the example that we looked at earlier allowed me to just introduce the concept of LOD. Why did we build LOD? Primarily to allow you to aggregate stuff at a different level than what you have in the view. But there's another way to use LODs, and we're going to base a lot of these examples on this single concept. So there's not a lot of theory that you need to know when you work with LOD, but this stuff here will save your life if you're trying to apply these techniques that we're going to learn today. So what are we looking at? This is the only slide, I promise. There is an order of operations. Things in Tableau happen according to following a certain predetermined order. And the first thing that happens, the first thing that is evaluated are data source and context filters. Then we evaluate fixed calculations, and then we evaluate dimension filters. And then we do everything else. What does this mean? This means that if I have an expression in my view that is a fixed calculation, a fixed expression, it's going to ignore my dimension filters. Now, this might sound like something that is completely crazy and dangerous. It's not. It's amazing, and it will allow us to do all of the following stuff. So just, if you remember one thing, remember this. Okay, back to our proportional brushing. I have prepared this beautiful calculation here that gives us the sum of sales aggregated at the level of every month. And by the way, how awesome is it that we can now use expressions like this in LOD? Thanks, Dav. So what does this do that is different from what I have in the view? Nothing. It's exactly the same. If we look at what we have in the view, we have sales by month. So if I bring this expression to my view, put it here, or maybe on a dual axis, it's giving me exactly the same result. But if you remember, the fixed expression will completely ignore dimension filters, which means that if I now select Latin America, I'll be able to see sales for Latin America in the expression, the original expression, and the other one will be completely unfiltered. Is this what we wanted? Is this the example that we had? Nope. Close. This is already an interesting use case, but our example is a little bit more advanced. So we do want our market filter to affect the other bar, but we don't want the country filter to affect it. So how do we do that? How do we do that? Any ideas? How do we make this dimension filter affect the fixed expression? Context. Yes, sir. If we add that filter to context, we will force Tableau to evaluate that filter before the fixed expression. So if I now go back to my example, take this filter here and add it to context, the bars will look, the lines will look the same, because now both metrics, both measures are affected by this filter. What's different now is that if I select Latin America and Brazil, or whatever, one of the two lines is not affected by this filter, because this is a simple dimension filter. So the fixed calculation is not affected by this. Let me synchronize this so it will look more similar to what we had originally. So now I am looking at sales in Latin America. This is the fixed expression, the black one. It's affected by the market filter, so this gives me sales in Latin America. And here I am looking at sales in Brazil, because this line is a simple sum of sales, and it is affected by everything, every filter that I had in the view. So going back, this gives us the ability to select something. Action filters are exactly the same as dimension filters. And yeah, this one is very easy. I just divide the first expression by the second expression. Making sense? Cool. This next example is super popular with customers. Being a product consultant gives you a lot of exposure. You probably all worked with a product consultant or a sales consultant at some point of your Tableau experience. You haven't? You've been missing out. We're awesome. Anyway, this is really popular with customers. This, what is market basket analysis? The ability to see what my customers purchase when they purchase something else. So if my customer purchased paper, have they purchased with that order what other items? So this example here gives me the ability to click on paper and see when customers buy paper, they also buy in the same orders binders, telephones, pretty much every other subcategory of products. But this is more interesting. 102 binder and binder accessories have been purchased in orders where the customer also purchased paper. And that makes up 11% of total binders sales. Okay? So how does this work? Again, LOD, one of these two bars is not affected by this filter. The other one is. It's the same trick, but with one more thing. When we click, we want to pass the order ID. We want to filter. We don't want to pass the subcategory. We don't want to pass the single transaction. We want to filter the other bars to display the same order IDs that contain paper. Okay? So that's the one additional thing that we need to do. Let's get to work. I have my calculation here. It's again fixing for every product subcategory the sum of number of items. It is exactly the same result that I have with this other one, but this is fixed, so it's not affected by action filters. So I mentioned that there is one more thing that I need to do. I need to have the order ID in the level of detail. So I want to add order ID to the level of detail here, which does two things. It breaks my bar, so now I have a lot of tiny little bricks, and it allows me to create an action filter that will pass the order ID. So now if I go worksheet, actions, I can create a filter on select, and I want to only pass order ID. So I select order ID here, hit OK. OK again. And when I click on paper, this one here is not affected at all. This is an action filter, dimension filter, fixed expressions, ignored it. This one is, so I am passing the order ID, the order IDs for orders where customers have purchased paper, to every other subcategory. So I'm looking at just the orders where customers purchase paper, and here I can see what else they purchased. And if I turn this into a dual axis, and just flip these, we have exactly the same look and feel, the same result that we had on the other one. Except for one minor thing. Now our blue bars are not very nice. In terms of user experience, of end user experience, this is not great. There is one more little trick that we can use using LOD, and it's to exclude the order ID from this other expression. So if I just do this, and I exclude the order ID from the sum of the number of items, and I turn these stack marks off, now I have exactly the same view, but now the bar is not broken. Cool? Making sense? Nice. And yeah, it still works. Why does it work? Why applying an LOD calculation to the other one didn't break it? Because if we go back to the order of filters, exclude LODs are different from fixed expressions, and they do respect dimension filters. Cool. Okay, next example. This is a really nice example, in my opinion, of using LOD to make your dashboards look nicer. We're not really adding any analytical value to this, well, maybe a little bit, but mostly, we are preventing this from looking ugly. So what are we looking at here? We have a dashboard that gives us profit over time, for a bunch of countries in the world. Again, I'm in pre-sales. I do dashboard polishings. I help our customers make stuff that looks nice and that is easy to use. If I saw this during one of our calls, I would say, this is horrible. Don't do that. This is a really bad idea. We don't put on color something that gives us something like this. We will never want to have more than, 10, 15 lines in a chart like this, because this looks useless. But then you might say, well, I do need this. I do need this because the purpose of this view is to allow the user to select something and compare it. So I want to select Italy, which is the beautiful country where I am from, and the UK, which is the country that I live in, and I want to compare them. If I don't have that on color, it doesn't work. Yes, it does, if you use LOD. In this other example, we have exactly the same view, except the one below the map doesn't look horrible. If I select Italy and the UK, I will be able to compare these two countries. If I deselect, Tableau just aggregates everything and gives me my profitability overall for all of my countries aggregated. Isn't that awesome? And if I select too many countries, it still aggregates them. I have a threshold here of 20 max. I never want to see more than 20 lines here. If I turn this into like 200, it will break it to show every country that I have selected. So how do we do this? Going back to 20, because this is breaking my heart. How do we do this? Any ideas? What do we need to know? We have a threshold of 20. What is the information that we're missing? Sorry? Exactly. We need to know how many countries have been selected. And how do we do that? Count distinct, yes. Except, if I do count distinct of country, what's the result? The count of countries by month. If I don't have any transactions for a country within a specific month, it doesn't show up. So I need LOD. If I wrap this in magic curly brackets like this, what will happen? I have a flat line, 140 something, 47. This is the total number of countries that I have in my data set. I have fixed that to the deepest level possible. I have aggregated that across all of my data. It's always going to give 147. So how do I make it so that this filter here affects this calculation here and gives me 2, 3, 4, whatever I have selected? How do I make a dimension filter affect a fixed calculation? Yes, 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 I've heard it. Don't be shy. Context. I need to add it to context. If I add this filter here to context, this now turns into a beautiful 4, which is exactly what I need to know. 4 countries have been selected. Okay? Now, the next step is, and I've cheated, I already have it here, to use this count distinct combined with this context filter to return country if and only if this number is smaller than the threshold that I've defined. So if the user selects less than 20 countries, this will return country, the dimension country. And this is what we will put on color. Else, return empty, all, whatever, it doesn't matter. Don't break it down by a dimension. Okay? So if I hit OK and bring this dimension to color, not here, but here, magic. This line chart is now showing me profit for all of the countries that I have selected. If I select a number that is bigger than the threshold, so we have selected 6, let's make the threshold 5, it doesn't break it up. It just returns all, and it aggregates the profit for all of the countries that I've selected. Isn't that amazing? Yes, it is. Okay, the next example is everybody's favorite map visualization. Everybody loves a path analysis. Again, I'm in pre-sales. I see examples from customers all the time. And sometimes when I see path analysis, it's really hard to make it useful. It looks beautiful. I would put this, I would hang it on a wall. But sometimes it's just not very useful. So this example here allows us to select a country. In this case, we have selected the United States. I'm going to move this to United Kingdom. And see only the lines that go towards that country. Okay? And by the way, this data is about foreign aid. So where is aid going from the country that I have selected here? Okay? This might seem easy to do at first sight. You might be thinking, so what is so complicated about this? This is expected behavior from a viz like this. Is it really? Let's take a look at the unfiltered view. This is a mess. We have all of the lines from every country to every country that we have in the data set. So you might be thinking, easy, we just filter it to only show data for the US. I'm just going to bring country and select United States. And this will only show me the lines that go from and to the United States. No. Surprise, surprise. Tableau does exactly what it's told, and it filters, and it keeps only the United States. We miss the other countries, the other end of the line. So this doesn't work. How do we make it work? I'm not going to ask you, do you have any idea how to do this? Because before you can have any idea how to do this, you need to know what the structure of the data looks like. And this is fundamental. In order, if you don't know that, in order to build a path on a map, you need to have your data structure like this. You need to have an ID for your line, for your transaction, and you need to have two lines. One with the donor, in this case, one with the recipient, the start and the end. Something that tells us where is it from, where does it go, and a number, a path, to tell us the order in which you want it to be drawn. If it's just two, it doesn't really matter. If it's more than 2 points, it's fundamental. So this is how data needs to be structured. And now, does anybody have any idea how to do this? This is probably the trickiest example of them all. Silence. We need to filter not the country, but we need somehow to preserve every edge where the country that we have selected appears. So in this case, we have United Kingdom. Let's go back to United States. That's easier. So here, we have United States, and we want to keep Afghanistan as well. So I've split this example in two parts. We have two calcs. The first one is our selected country calc. And it's very simple. It returns 1 if the country equals the country parameter. So if I have selected in my parameter a country that matches the country in the country dimension, give me 1, else 0. Easy. Let's bring that to the view and make it bigger so you can actually read what's going on. Okay, now we do have a number 1 wherever we have the US. Let me just move this path for you because it's confusing. Wherever we have US, we have a 1. Now, we need somehow to turn this into a 1. So we're then going to use the expression as a filter. We're only going to keep the 1s, and it will work. So how do we make it so that everywhere that I have a 1, the other country within that edge will also have a 1? Max. We need to aggregate a max at the level of what? Edge, yes. So that's exactly what this other calc that I called fixed calc do. We fixed at the level of edge the max of this other expression that we calculated before that gives us the 1 wherever we have the country that we have selected. And surprise, surprise, if we drag this here, and again, make it bigger. Dev, can you do something about this? Why does it resize every time that I bring something new? What's going on with that? Come on. So now the one has propagated magically to every recipient as well. Let me put that on color so it's easier for you to see. Color. Wherever we have a 1, the other end of the edge will also have a 1. If we use this as a filter and not on color and select just 1, we will have all the edges and all the countries connected to the United States. And now if we go back to our map, remove this filter, and use this other one as a filter, this, it works. Because we're not filtering out the other end of the line. Cool. Ooh, this example is awesome. It's one of the most analytically interesting and clever, I think. So what are we looking at here? We have a dashboard that is used by an exec to evaluate performance of our company compared to the performance of our competitors. So we have one scatter plot here that gives us year-over-year growth and sales. And again, this is fake data, which you can probably tell by the fact that our company makes more than the GDP of some small countries. So yeah, don't go looking for income corporation. I don't even know if that exists. That's it? Okay. Ah, okay. I didn't know that. It's a Star Wars reference, apparently. Okay, so what else do we have? We have year-over-year growth and sales. And here we have a comparison of our year-over-year growth compared to the other companies' year-over-year growth in every industry that we operate in. So now we don't have anything selected, so we can see that compared to the average year-over-year growth of every other company that we have in the data set, we have grown more in most of the areas that we operate in, except for grocery. Other companies have grown more than we have in that sector. If I select Income Corporation, which is our biggest competitor, it appears. Then we can see that even here we are growing more than they are in most of the industries that we operate in, except for grocery and this, clothes, shoes, and jewelry. What's going on here? We're too slow. We're growing too slowly compared to our biggest competitor. That's where we need to invest next year. So this is really good in terms of analytics. It's not that easy to do without LOD. Let's take a look at the why. In general, in Tableau, and in pretty much every other analytical tool that you will use in your life, it's easy to compare columns. It's easy to compare expressions that you have in different columns. It's not so easy to compare rows. So because of the data and how it is structured here, we have a field, a dimension with company, and that includes our company as well. So we have the competitors and ourselves. And we have the one metric that we need, which is the year-over-year growth. It's not easy to compare analytically this 29% with this 24% because of how the data is structured. You can do crazy unions or blending to make it work, but with LOD, it's a lot easier. So let's take a look at how we do that. We have 3 calculations here, and let's take a look at what they do. The first one, very simple. I'm not going to explain how it's done. You all know. We'll just extract the data for our company. So it returns the data for our company and null everywhere else. What we need to do now, in order to be able to compare this 29% with this 24.5%, is to have this here. We need to propagate this value across every other company that we have in the data set. That's where LODs come in. Just drag this other expression here. This gives me the same value replicated across subcategories for every other industry. So every subcategory, regardless of the industry, will give me the same result, which is our year-over-year growth. How do we do that? Take a look at this expression. We are simply taking the min or the max, doesn't really matter, of that first expression that we had that gives us our year-over-year growth and null for everybody else. And we are aggregating that, we're fixing that at the level of product category. So this checks, okay, what's the min between null and 29? It's 29. Or what's the max between null and 29? It's 29. So it takes that value and it propagates that across every company. And now it's trivial to just take this and subtract this and have the number that we need. That's what this third calculation does. And that's the result that we have. Of course, it's 0 for our company. The difference in year-over-year growth between us and us is 0. For every other company, we are calculating this subtraction here, 29 minus 24.5, 4.6. Making sense? Very well. Okay, the next example is about retention analysis. It's nothing new, again, in terms of how we're going to do this. Similar concept to some things that we've seen before, but again, analytically very, very interesting and very, very powerful. So what we want to have here, what this view is built for, ooh, that's not good. Help. There was a bag there. Why is it not working? It's a Dell. There was a bag there. That one. Sorry. No, it's not the right one. Sorry. Yay. We made it. Thank you, guys. Okay, so what are we doing? Retention, yes. So normally, filters in Tableau are applied as OR filters. So if we select a number of quarters, and we have a list of customers, we will get the list of customers that have purchased in at least one of these quarters. The purpose of this visualization is to show us the customers that have bought in all of those quarters. So if I keep selecting quarters, I will not get a bigger list, I will get a smaller list, because only a few customers have purchased consecutively in 5 quarters, from Q4 2013 to Q4 2014. Making sense? So how do we do that? How do we make normal filters turn into AND filters so that we know customers that have purchased in all of these quarters? Let's take a look. Does anybody have any idea what we need to know? What's the information that is missing? Yeah, that's the end goal. We need to know how many quarters have been selected. This is a similar example to what we have done earlier with the countries. We need to know how many quarters have been selected. 4 in this case. So we need that number. And it's very easy to do. We need to do a count distinct, in curly brackets, count distinct of our quarters. I'm using a custom date just because it's easier. Again, I could use an expression. We can do that now in LOD calculations. And this, I already have added this to context. This filter is added to context. So this is giving me 4, the number of quarters that the user has selected. I select one more, turns into 5. The next thing that I need to know is how many quarters out of the 4 that I have selected have these customers made a purchase in. And to do that, I need to do something similar. Let me do this here because it's a bit bigger. I need to fix, number of quarters, customers. That's not English, whatever. I need to fix, at the level of every customer name this time, the count distinct of the quarters. And this metric here is different for every customer. This one is valid across all customers. It's just aggregated at the level of the entire data source, and it's giving me 4 across every customer. This one is specific to every customer. Out of these 4 quarters that I've selected, how many quarters has this customer made a purchase in? 2. We only have a handful here that have made a purchase in all 4 quarters. One of them is Shahid. So what I need to do here is just take this expression here and make sure that it's equal to this other expression here. And it doesn't work. Let's do it here. This equals this. Yay. And now, if I put it on color, it's going to be very easy to see that Shahid and Mick and some other people have purchased in as many quarters as I have selected out of all these 4 quarters. And then I can use this information as I want. So I can use this as a filter rather than as a dimension to color. And this will give me the list of customers that have made a purchase in all of the 4 quarters that I have selected. Cool? Yay, thanks. Okay, this takes me to our last example. I believe you've been shown something quite similar this morning. We are working a lot on how to overlay information on maps. This is something that is going to become very easy to do in the future. I decided to keep this example, first of all, because I prepared it, so I don't want to remove it. But no, most importantly, because it's available now. So it's something that you can do now as you wait for all the cool stuff that we're going to release next. So this is a very simple map. It gives us profitability by state for every state in the US. Now, normally, what you have to do if you want to have this combined with the profitability for every city, you need to have 2 maps. And use one as a filter, and you click on California, and you will see a map of all the cities in California and their profitability. Wouldn't it be nicer to be able to do this? Boom. We keep only one state, and this map drills down to that state and shows us the cities for that state that we have selected. Isn't that cool? So how do we do that? Let's go here, and let's take a look at these calculations that I have prepared. It's the same concept, really, to something that we have already done, right? We need to know how many states we have in the view. If we have 49, which is the number of states that we have in this data set, then, when I have set that as our drill down threshold, if we have less than that, it means that we have made a selection, that we have removed some states, which means that the user wants to drill down. So if that's the case, give me the cities. Else, nothing. And then we have the opposite. So if the number of states is bigger or equal, this could be equal, to the drill down threshold, then give me the state. Because if it matches the number of the threshold, it means that no selection has been made. So we should be displaying the states. Okay? So what I need to do now is to replace this, the standard city dimension that I have in the data and that is in this view with this fixed calculation. So I'm going to replace my city in this map with a show or hide city, and I'm going to do the same with state on the state map. And by the way, I've also applied city as a geographic role because it wouldn't recognize it automatically because it's a calculation. So now, if I keep only California, it doesn't work. Why? I know why. Context, yes. If I add this to context, this calculation, the count distinct calculation, will work, and it will give me the result that I want. If I make it a dual axis now, I will have exactly the same result that we had in the previous dashboard. And exclude or include filters can be visualized as lists, as normal dimension filters, which means that I can reset this view by just selecting all. So I can add this to the dashboard, and a user can just click on a state, drill down, and then reset it using all. Isn't that cool? Okay, I promised I would only show one slide. I lied. I'm going to show it again, but it is the same slide, so it's a small lie. This is super important. Have you noticed how every example, except for the first one, that was easy, was created following these rules? It's super important that you know about the level of operation, the order of operations, and when things happen in the pipeline. Okay, so that's the end of the material that I've prepared for you today. The session is going to be repeated tomorrow and Thursday. We're going to have time for Q&A, so if you want to stay for Q&A, just give me 1 second. I just need to give you some information. If you want to recommend the session to your friends, it's repeated Wednesday and Thursday. If you want to go to some related sessions, we have Pick Your Poison, LOD expressions, or table calcs, super interesting. And we have artful data, the balance of art and analysis, that I think are going to be very relevant for you guys. And please, please, please give feedback. We really need to know if you liked the session, if there's anything that we need to change, or if you loved it. I hope you liked it. And now we have time for Q&A. Level. Thank you very much then. If you were shy and didn't want to ask a question, I'll be here for 5 to 10 minutes. You can come here.